This is Module 9, Lesson 4. We are going to leave moles behind for just a moment while we talk about percent composition. We have percents more than once in this class, and one thing that I hope that you remember is that anytime that you have percentage, a percent of anything is always over the whole times 100. This particular formula is not given to you anywhere on the reference table, so you are left to have to know how to find a percent of anything. So as we do percent composition of compounds, you'll find that it is part of the compound over the whole compound. So right here is kind of our formula, if you will, for how to find the percent composition. If it asks you to do the percent composition of something, say, sodium chloride, so if it wants the percent comp of NaCl, that means we're going to percent Na and we're going to find the percent of Cl. How you do that is you do the mass of the element over the mass of the whole compound times the 100 to make it a percentage. So if you have printed out your notes in your practice for Module 9, Lesson 4, you have this as your first type of problem. Up at the very top of the page, it says 2 ways to have problems. And the first type is this. It'll say find the percent composition of water. In my case, I have water, but it could be any particular substance, any particular compound that you could be given. So if we need to do the percent composition of water is 2. And so what you're going to do is you're going to find the percentage of every element that's in that. So for this one, there'll be a percentage of H, and we need to find if it was something, for example, let's say glucose that has 3 things, then you would find 3 percentages. You would find the percentage of carbon, the percentage of hydrogen, or the percentage of oxygen. Okay, so for this one, I'm just doing the H and the O because that's all that's in it. So in order to do this, I need to do the mass of H over the mass of H2O. Now, when you're doing these, you don't necessarily have to write out the formula every single time. I'm doing it so that you understand my thought process to get these numbers. So the mass of H and H2O. Now this is where, like we've been doing the molar masses, we're going to use that exact same thing. The mass of the H's in this is 2 because hydrogen has a mass of 1.0 and there are 2 of them, so that would be 2.0. Now if you find the mass of H2O, that's going to be 2.0 for the H and 16 for the O. I'm using my reference table to come up with these just like we've been doing. So if you add those together, you'll get 18 grams. So we're going to divide that and multiply our answer by 100. So if you put that in your calculator, you should end up with 11.1%, 11.1 repeating. Now on these, it's kind of impossible to do sig figs when you aren't given any numbers to start with. So I'm asking you in the problems to just round it to a decimal place. Now, if I was given numbers, and I'll show you an example out of in a minute, we're going to round to the number of sig figs that were given to us in those particular problems. But for now, just, no numbers, round it to a decimal place. If we're going to do the percent comp of oxygen, well then, in this case, the amount of oxygen, mass of the H2. We've already figured these out up above. So the mass of O, we said, was 16 grams. And the mass of water is 18. So multiply that by 100 and get 88%. Okay, so there you have it. It is 11.1% H and 88.9% O. We just did the percent composition of our first substance. Okay, now if you notice and you think about this for a second, most likely these will add up to 100%. It is possible, I've seen it happen, where occasionally they add up to 99.9% or like 100.1% because of rounding. So if you do get that, don't completely freak out that you've done it wrong, but you can definitely do a double check to make sure that you're that close. If you end up with like 96% or 98%, you've done something wrong. You should either have 99.9, 100, or 100.1. I don't know how much of the time, but it's more than half. You should end up with 100%. Okay, a second type of problem. This one gives us numbers. So this one says a substance is found to have this much carbon, this much hydrogen, and this It wants us to find the percent composition of the compound. So same end goal, but I don't have a formula. So I know that I'm going to find three things. I'm going to be finding the percent C, the percent H, and the percent Cl, sorry, percent chlorine. So how am I going to go about that if it doesn't give me a formula? Well, it gave me numbers. So what we need to do is we do the mass of the C over the mass of C plus H, the whole thing. Well, we've got numbers for that. We have a number for C, a number for H, and a number for Cl. To do the mass of H, we'll do mass of H over the mass of C plus HCl. Chlorine will be the idea, except we'll do the mass of chlorine over that whole thing. Now, the nice thing is once I do the bottom one time, I don't have to keep doing that. All of these will be times 100. Otherwise, we just get a fraction. Okay? And we'll have an answer. Let's just do the first one. The mass of C that's in this. I am not going to my reference table this time because the mass of C that was given is 10.68 grams. That's where I'm getting that from. The mass of all of those, if you add together 10.68 plus 0.84 plus 94.16, I've already done this. And honestly, I don't know what that is. I didn't write down that number. So 10.68 plus 0.84 plus 94.16, I'll do it for us now, is 105.68. On my paper, I just wrote down the math. Like I wrote them all down. This plus this, but you can do that too. But that's kind of laborious to keep doing it. Oops, and that's times 100. If you do 0.68 divided by 105.68 times 100, you will get an answer of, let's see, 10.105. My dot, dot, dot. Remember, my dot, dot, dot just means that there's many more digits on my calculator, and I'm not writing them all down. So how do I round it this time? Well, this time we need to go by our sig fig rules. You did have sig figs given to you. And remember, with addition and subtraction, it has been a long time. So when you do addition and subtraction and you add these together, like this, line them up, you need to go back to module 1, I don't remember which lesson 3, lesson 4, back with the sig figs, that when we add this up, it's based on decimal places. All of these are 2 decimal places, which means this number will be good. I don't need to round it at all. This has 4 sig figs and this 5. When we do the division here, 4 is less than 5. I get to keep the 1 0 and the 1 0. That's going to round to 10.11% carbon. Okay, there's my answer for that. All right, my second one, the mass of hydrogen here. Don't you dare look at the reference table, go to this. It's going to divide by 5.68. I'm just using the same number that we had up above, times 100. All right, when I do that, and let's see, I don't have it to quite enough sig figs on my paper. I will get this. I will get 7, oops, been a while since I've done it, 7.94, or it's 0.7, sorry, 0.79485 dot dot dot. How many of them I keep? Well, it's the same thing as before, except this has 2 sig figs. This has the same 5 that it had from before, so I can only keep the first 2. That's going to be 79% H. Does that make sense that it's that small? It should, because hydrogen weighs that little, like it's a very small number. Then our last one, we need to do the mass of the chlorine. The mass of the chlorine was 94.16, and that is over 105.68 times. Okay, do that part in our calculator, and we will get, whoops, I skipped ahead somehow as I did this. We will get 89.09916, and it goes further. Okay, this has 4 sig figs, this has 5, we can keep 4. So that 9 beside of the 9 we get to keep is going to round it up. So that's going to be 89.10% chlorine. Okay, so this is easier in some ways because we're given the numbers, harder because now we're left to deal with sig figs. So keep in mind that when you take a checkpoint on this, you're going to be required to round based on these rules, which means if you just simply try to Google these problems, you may find answers that aren't doing the rules that I taught you with the rounding. So don't get yourself in trouble. If you don't understand the rounding, then see me for office hours so that you know what to do. Okay, you have practice problems on your paper. So you have 2 choices. You can either pause this right now and try those practice problems that are exactly like these 2 problems that we just had. Or you can go ahead and you can do the 3rd type of problem and then just do all of them at once. That's up to you. So here's the last type of problem. And you'll have to turn the pages in your notes to get over to this point. I do have it in your notes to like stop and go back to the video for the next part of the lesson. So if you chose to go ahead, then review it if you need to. But we can use the percent composition to do another type of problem. So this type of problem says calculate the mass of zinc in 30 grams of a sample of this compound. And these types of problems will be formatted the same way. They'll ask you to find the mass of a substance in a certain amount of another substance. So you might be thinking, how am I going to do that? Well, here's our first step. The first step is going to be this. You need to find the percent composition of the element that it's for. So you need to find the percent zinc. So to do that, it will be the mass of zinc over the mass of that whole compound, the ZNO32. Oops. I thought my computer was plugged in, so apparently I'm having issues there. So it is going to be that percentage. So what we're going to do next is we're going to do the mass of zinc, and remember that's times 100. So that's going to be 65.4 grams using the periodic table, and then this using the periodic table is 194. When you multiply that by 100, you'll get 34.5 other numbers percent zinc. What I want you to do is to save all those digits or write as many of them as you can down on your paper. Because this is not our final answer, I don't want to round it. The proper way to do it would be to keep all of those digits. The second thing that we're going to do is going to use the percent comp to find our answer. And how are we going to do that? Well, if we have 30 grams of this sample, 34.5% of whatever we have will be zinc, no matter how many grams it is. So we are going to take that 35.5 however percent, and we're going to multiply it by 30 grams. When we do that, we're going 1.3590 blah, 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 blah in the calculator grams. Now, don't forget that when you multiply by a percentage, you either need to divide by 100 and multiply by 0.345, all the other numbers, or you have a percent button on your calculator that you need to use to multiply by. If you're not getting the 10.3, that's me so that I can help you with that. Now, in terms of sig figs, what do? Well, the only number that was given to me was this one. Everything else I came up with. That means that all of this stuff has an infinite number of sig figs, and so does this. This has 4, so my answer needs to have 4 sig figs. I can keep those 4 digits. The 9 beside it rounds me up, so that'll be 10.36 grams of zinc will be your answer. Now, you have more of those on your paper. You do the exact same steps. Find the percent of the element it's asking for, and then use the percentage to multiply it by the amount of the substance that was given to you to find your answer. Okay? If you have questions, you can let me know. You have the practice problem to do, and you know where I am if you need me.